Okay, welcome to the Know and Use part of this Unit 6 AP7. Draw the graph of y equals 2x squared minus 4x minus 1 for values of x from minus 2 to plus 3. Do this on separate graph paper. So I gave you some proper graph paper, but I've just got some squared paper to demonstrate to you exactly the same sort of thing. First thing is, when we have a multi-part polynomial or a quadratic or a cubic, polynomial means I've got sort of several parts to it, or it's raised to the power, and here I'm going to have a look at what the values of x are. So I want it for values of x from minus 2 to plus 3. So yeah, so first here I've got my row, which is, this is my value of x, so it's going to go minus 2, minus 1, 0, 1, 2, 3. I'm splitting it into its parts when I'm tackling this sort of question. So one part is 2x squared. The next part is minus 4 lots of x. And the next part is take away 1. So I'm just going to substitute in as we go. And then y is the sum of all those things put together. So this is my y. Okay, so 2x squared. Well, when x is minus 2, I've got to remember my BIDMAS rules. I'm going to do the squaring first. So minus 2 squared is 4, 2 lots of 4 is 8. Minus 1 squared is 1, 2 lots of 1 is 2. 0 squared is 0, 2 lots of 0 is 0. 1 squared is 1, 2 lots of 1 is 2. 2 squared is 4, 2 lots of 4 is 8. And 3 squared is 9. And 2 lots of 9 is 18. Okay, minus 4x, here's where most of the errors creep in. This is minus 4 times by minus 2. Minus 4 times by minus 2 is plus 8. Minus 4 times by minus 1 is plus 4. Minus 4 times 0 is 0. Minus 4 times 1 is minus 4. Minus 4 times 2 is minus 8. And minus 4 times 3 is minus 12. Now, with this one, I'm not going to substitute any x's in. There is no x component. It's just take away 1 across the board. So that's taking away 1. No matter where you are in terms of the x value. So, got 8 plus 8, 16, take away 1, 15. 2 plus 4 is 6, take away 1, 5, 0, and minus 1, minus 1. 2 take away 4 is minus 2, take away 1 is minus 3. 8 take away 8 is 0, take away 1 is minus 1. 18 take away 12 is 6, take away 1 is 5. There we go. So I've got my coordinates I can plot. Before I do that, I need to make sure when I'm drawing my axes that I've got between minus 2 and 3, and it's going to have to go up as high as 15 and at least down as low as minus 3. So I'm bearing that in mind when I then draw in my axes. I'm going to see if I can zoom out a little bit. Oh. Okay, that's done it. Okay, so first thing is labeling this. I mean, the way I've done it with graph paper, you've actually got more flexibility. But I've done it so I've got one square here for each one of y, and I'll have a look for the x in a minute. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it wants to go down at least as far as minus 3. Well, I've gone down as far as minus 5. There we go. Now, I just need to go from minus 2 to plus 3. But if I just use this bit here, so if I kept the same sort of scale for the x-axis, it would all be really squashed in. So I'm going to separate it out, and I'm going to give a full 5 squares for each value of x. So for each unit of x. So 1, 2, 3, 4. That will be where my 1 is. 1, 2, 3, 4. That will be where 2 goes. 1, 2, 3, 4. That will be where my 3 is on the x-axis. And then I've got to keep it here at the same scale. If I can't change my x scale over the scale I'm using. So 1, 2, 3, 4, 5. That's minus 1. 1, 2, 3, 4, 5. Minus 2. And now all I need to do is plot it. Right, when x is minus 2, y is 15. Be careful. Take care with your plotting to get it absolutely right. There's my minus 2. There's 15. Plot. Minus 1 and 5. So minus 1, 5. 0 and minus 1. 0, minus 1. 1 and minus 3. Okay, 1 and minus 3. 2 and minus 1. 2 and minus 1. And last one, 3 and 5. So 3, 5. If this doesn't make a smooth U curve and it's a positive x squared, or a smooth upside down U if it's a negative any sort of x squared curve, you know you've gone wrong. If it's kind of wiggly or something like that, you've made a mistake. If it's an x squared curve, you know that an x squared curve is a parabola. So think again, you've made an error. Usually something around the negatives. Often inputting it into your calculator and relying on your calculator to do this instead of your own brain to do this bit. And remember, when you put this into your calculator and you don't put the minus 2 bit here in brackets, then your calculator does it wrongly. Okay, so you need to be super careful about it and trust your own brain rather than a calculator, and trust your own knowledge of what an x squared curve looks like to check it. Right, all I need to do now, I'm doing this with a pen. Obviously you would do all this with a pencil. The only reason I'm doing it with a pen is it shows up better on the video. And I'm going to connect together these with a nice smooth curve if at all possible. Okay, I'm going to turn the paper as I do so because that helps me with drawing a nice smooth curve. Yeah, I'm quite happy with that. And just for the sake of completeness, I'll label that y equals 2x squared minus 4x minus 1. Happy. Okay, part B of this question says an approximate solution to this graph when that is equal to 0 is x equals 2.2. Well, let's have a look at this. This is just saying this bit, look, y is equal to that bit. So when this bit is equal to 0, it's when the y value is 0. So I have a look on here. Yes, look, my y value, look at mine. It's almost going exactly through 2.2, that approximate, the approximate solution where x is 2.2. When y is 0, x is 2.2. It's also here. Okay, what's the value of x there when y again is 0? Well, it looks like it's just less than it's just less than minus 0.2, just a bit lower than minus 0.2. I'm going to say it's x equals minus 0.25, but you'll have flexibility there as long as it corresponds to your graph. You know, this will be correct if it's anything probably from 0.1 to 0.4. So minus 0.1 to minus 0.4. Okay, so let's move on to question 2. If you did get this wrong, guys, it's very, very important that you take time to do a good quality correction and a good quality graph here. And make a note where you went wrong. Is it because you trusted your calculator? Is it because you didn't work your negatives out correctly? In any case, make a note that if you've got some other curve, you know that it can't be right if it's got an x, if the highest exponent of x is x squared. Okay, let's have a look at question 2. Below are some graphs. Okay, well, let's have a look then. So this one, I've got a negative gradient and it's linear. So let me have a look. This one, it can't be this because that's a quadratic. It can't be this because that's a cubic. So I've got two linear graphs here. Now this is the sort of format that you're most used to seeing, a sort of y equals mx plus c, or format. In this case it's just minus p, but it's in that same format. So you know here the gradient's 3, so there's a positive gradient here, so it can't be this. This one's a negative gradient. Okay? And you could see that by rearranging it into y equals mx plus c if you wanted to. So I could rearrange this and say, right, 3x plus 4y equals p, so 4y equals minus 3x plus p. I just took away 3x from both sides. So y equals minus 3/4 x plus p over 4. Or this. But in any case, I've got a negative gradient there. Once I put it into that format, this is c. We've got a negative gradient. It can't be this one because I can see that there's a positive gradient. And look, with this one, I can see it's a positive gradient and the intercept will be less than 0 on the y-axis, so it's definitely going to be that one. And this is a cubic shape, so it's got to be equation D. And that's the end of your known use section.